Hey guys, Mr. Middleton here. And today we're going to look at law of sines notes. At the end of this video, you should be able to determine when law of sines is appropriate to use. And you should be able to use law of sines to find missing angle measures and side lengths. All right, so as we look at this triangle, why would we not be able to, it asks us to, if it asks us to find the missing side lengths, why would we not be able to use trig on this problem? Okay. And our answer should be pretty quickly that it is not a right triangle. Okay, and we can only use our SOHCAHTOA on right triangles. Okay, so today we're going to change that a little bit. We're going to introduce law of sines. And this allows us to find all the missing pieces of this triangle. Okay, and it works for any triangle, not just right ones. Okay, the law of sines is basically a ratio that we can use in order to find missing information if we have a complete side. Okay, so A over sine A equals B over sine B equals C over sine C. Remember that we use the lowercase letters A, B, and C to show side lengths, and angles are using capital letters. We could walk through the proof. I'm going to skip that for your time. All right, let's just practice with it. It says use the law of sines to find the indicated side lengths and angle measures. Okay, find the length of C to the nearest hundredth. All right, so like I said, for law of sines, what we need to have is a completed ratio. We need to have a completed ratio of a side and its opposite angle. If we have that, even just once, we can find all the missing information in the triangle. Okay, so in this problem, you'll notice that we want to find C, and we're given the angle for C. So if we kind of like plug in some stuff right now, we're not given anything about B. And then for A, we're given A, which is 15, and we're given sine A, that angle is 77. Okay, so now we have this completed ratio, and so we can use the law of sines to find out what C is. Because the ratio, law of sines tells us the ratio of 15 over sine 77 should equal C over sine 23. And now I just need to solve for C. Multiplying both sides by sine 23. Okay, and so what I have is 15 times sine 23 over sine 77 should equal C. Okay, I want to be careful about putting that into my calculator, but that's all it is. So 23 sine times 15. I'll write this down here just so I can check my stuff later. All right, divided by sine of 77 equals 6.015. So C equals 6.015. The directions say to the nearest hundredth. That's two places. So we should say that C is 6.02. All right. So being organized, making sure that we have our corresponding angles and sides together is really the secret of law of sines. Okay. Number 2. It says find the missing angle measure to the nearest tenth of a degree. Again, as we look at this, not necessarily have to lay out the law of sines as we did last time. We just know, hey, these angles and this goes together. And so we can say, okay, sine or 11 over sine 50, because those are a corresponding angle and side, right, should equal 7 over sine x. So as I get done with this, I'm going to start by getting x out of the way. I want to get it out of the denominator. So I'm going to multiply both sides by sine x. Okay, and so when I do that, I get 11 times sine x over sine 50 equals 7, right? So that first thing got sine x out of the denominator, put onto the side. Now I need to get x by itself, so I'll divide both sides by 11, right? Divide both sides by 11. And so I'll have sine x over sine 50 equals 7 over 11. And then finally, I'm going to multiply both sides by sine 50. So that gets me, I'm going to go up here. Sine x equals 7 times sine 50 over 11. You'll notice here that we're trying to find an angle, and so how do we get rid of sine? We have to use inverse sine. So x should equal the inverse sine of 7 sine 50 over 11. So I'm going to do sine 50 times 7, right, divided by 11. Okay, and we have to do the inverse sine of that. So inverse sine of that number, and that gave us 29.175. So x equals 29.175. Our directions say to the nearest tenth of a degree, so that's 29.2 degrees. Finally, one last problem. It says in triangle FGH. So I'm going to draw that triangle out because it'll be easier to think about it when I can see it. In triangle FGH, FH is 7, HG is 12, and the measure of angle F is 72 degrees. Okay, it says find each of the remaining angle measures and side lengths. Give angle measures to the nearest degree and side lengths to the nearest tenth. Okay, so as we set this up, I'm going to say 12 over sine 72 should equal 7 over sine g. Okay, I want to find out what x is, or what g is, I guess, for this part. Okay, so here I can solve this. I'm going to cross multiply. I've got 7 sine 72 equals 12 sine g. I'm going to divide both sides by 12 here. And so in my calculator, 72 sine, okay, so sine of 72 times 7 divided by 12 should give me sine g. So I know that sine g equals some number. 7 sine 72 over 12. So in order to find g, I need to do the inverse sine of this. Inverse sine of 7 sine 72 over 12. So back to my calculator. All right. And so I'm going to do trig inverse sine of that number, and that should give me 33.69. So it says to the nearest degree, so I'm going to say 34. So G equals 34 degrees. Okay, so G is 34 degrees. That means that H should be pretty easy to find, right? Because these have to add up to 180 degrees. And so 72 plus 34 minus 180, that gives 74. Okay, didn't even have to use law of sines there. Okay, so from there then, in order to find the missing part FG, we can set up 12 over, I'm just going to use a different color, 12 over sine 72 because we're sure that that ratio's what it's supposed to be, so we'll use that, equals 74, or sorry, I'll call it H over sine 74. So just trying to get rid of the 74 here, or sine 74 here. I'm going to multiply both sides by sine 74. And so I have 12 sine 74 over sine 72 should equal H. These are my calculators, 74 sine times 12 equals divided by 72 sine, and that gives me 12.12, or 12.1 to the nearest 10. Okay. All right. So that is law of sines. See ya.